Okay, in this section, we're going to talk about the addition rule for probability in 4.3. Proverb for this section: wealth gained hastily will dwindle, but whoever gathers it little by little will increase it. In other words, stay away from get-rich-quick schemes. I've seen a whole bunch, heard a whole bunch. Of course, people get rich, but be very, very careful. It's better to just save, be a good saver. That is also a preview to a lot of games that we're going to be playing. A lot of people think that they can go into a casino, play a certain probability game basically, and get rich that way. That's not how it works. Here's a couple of definitions before we do some exercises. A compound event, any event combining two or more events. An example of that: if we roll a pair of die and A is the event that the sum of the die is 5 or the sum is 3. So 5 or 3. That would be a compound event. Some notation: we can have probability of A or B. We have the probability event A occurs or event B occurs or both occur. That's the same thing. And then general rule: add the total ways A can occur and the total ways that B can occur, but do not double count. And that's very important, that we make sure that if there is an intersection where you have some parts in event A are the same as event B, then you do not double count them. Okay. Formal addition rule, you can write as probability of A or B is equal to, you find out what the probability of A is. What's the probability of A? Find the probability of B, and then subtract one instance of probability of A and B. And A and B is the intersection where A and B both occur at the same time. Another alternate form, A union B here, A union B, is the same thing as A or B, is given by probability of A plus probability of B minus the probability of A intersect B. So the upside down U here is the intersection symbol, and it's the intersection for the and. Two events are mutually exclusive if they cannot occur simultaneously. For instance, flipping a coin, you get only heads or tails, but you can't get both. And then usually in the classroom, you can share an example or two of two mutually exclusive events with your neighbor. Something that has no overlap. So as you guys are thinking about that really quick, though, I want to share with you guys here a picture. So if I drew a square to denote my entire sample space of stuff that could happen, like rolling a pair of die and getting a certain number, and then I say that this circle in this Venn diagram is going to represent event A, whatever that event A is, and then this circle here is going to be event B. Well, if I want to figure out what probability of A or B is, probability of A or B, that means getting one or the other, or possibly something in the intersection, if there is something in the intersection. Well, this is the same thing as saying, let's say probability of A is going to be blue. What's the probability of A? That's represented by this circle right here, right? That's that circle, probability of A. That, if you think about this geometrically, that area of that circle would be its probability, plus the probability of B, which would be denoted by this circle right here. So did you notice that when I calculated counted the probability of A, and then calculated the probability of B, I counted this intersection right here twice? That intersection right there was counted twice. And so that's why I need to subtract the probability of A and B that happened at the same time, because I don't want to count it twice. I only want to count it once. Here's a piece, right, to count. Here's a piece, and here's a piece. There are three things that we need to count, and so if we double count the intersection, then we need to subtract one of the copies. And that's the bottom line. Do not double count when there is an or. There are these words that will give you the understanding of which rule to use. There's going to be multiplication rule in the next section. In this section, please associate or start associating the word or in probability with the addition rule. Okay, so Let's actually draw a picture for mutually exclusive sets as well. It's on the next slide. So if they're not mutually exclusive, that means they have some overlap, like in the first picture here, right? Not mutually exclusive is this situation. They have some overlap. And in that case, what I need to do is subtract out one of the copies. So if I find out what probability of A is, find out probability of B, this intersection was counted twice, and I subtract one copy. If the two sets or two events are mutually exclusive, that means there is no overlap, then I don't have any intersection to subtract. It's just find the probability of A and add to it the probability of B when you're being asked to find probability of A or B, right? Only if there's some overlap, if there's an intersection, when there is an or probability being asked, or you're asked to find probability of A or B, then you will subtract one copy of the intersection. And then if they're mutually exclusive, you're not going to subtract anything. Here's more of a diagram. Probability of A or B, addition rule. Are A and B mutually exclusive? If yes, then you just add probability of A and probability of B. If no, then you have probability of A plus probability of B minus their intersection, probability of A and B. Okay. So a question that could be asked, and you should assume that I can ask something to this extent on the test or quiz. Let probability of A, there's two different events here, or two different things that are happening into the two columns. Let probability of A be 2/7, probability of B be 3/7, and probability of A or B be 5/7. And the question is, are A and B mutually exclusive, right? Well, you can figure this out and see if we have probability of A plus probability of B equaling probability of A or B. If that's the case, if there is no intersection that I need to subtract, then they are mutually exclusive. So let me write this out here. We have 2/7, and 3/7 equals 5/7. And so if we take a look at this, if we're being asked to find probability of A or B, probability of A plus probability of B minus probability of A and B, right? And we now put in the values. Well, probability of A or B was 5/7, right? Let me go back to the slide. Probability of A is 2/7, that equals 2/7, and the probability of B is 3/7. Well, I'm not told what probability of A and B is, right? But I need to figure out what that is. And the only thing that I need to find out is whether it's 0 or not. Well, let's think about this. Take a look at this equation and say, if I add 2/7 and 3/7, do those add up to 5/7? Yes, they do. That means over here, this question mark gets to be replaced with 0/7. And since there's nothing in the intersection is empty intersection, that means A and B are mutually exclusive. A and B are mutually exclusive, right? Whereas, take a look at the next example. If I use the same formula, probability of A or B, we had probability of A or B is 4, or C or D, I guess. C or D is 4/7. I'll write that out. Probability of C or D is equal to probability of C plus probability of D minus probability of C and D. And I really suggest that you write out the formula. So probability of C or D, and then fill it in. 4/7 is equal to, probability of C is 2/7, probability of D is 3/7. And so the question is there something that I have to add or subtract to be able to get 4/7? And yes, I do, because if I just add 2/7 plus 3/7, that is 5/7. Those are not equal until I subtract 1/7. And so since I have something in the intersection here, let me write that a little bit more carefully, not empty intersection. There's something in the intersection. That means these two are not mutually exclusive. C and D are not mutually exclusive. That means there is an overlap, and that's why we had to subtract one copy of that overlap. Okay, so I hope this helps in deciding whether two sets are mutually exclusive or not. See if it fits the formula. If there is something in the intersection, then you must assume that they're mutually not mutually exclusive. If the intersection is blank, if the probability is 0, then they are not. Then they are mutually exclusive. Okay. Suppose we roll a pair of die. Here's another example. Let A be the event that the die add up to 8. Let B be the event that one of the die is 5. And so we want to find the probability that A happens or B happens or both. We have to be really careful about this. So we roll a pair of die. We have either the event is that they add up to 8 or one of the die is a 5. Okay? And so when we count this, we need to make sure that we do not double count. Let me do this first instead of looking at the slide here by hand, since I already had it drawn out right here. So if we take a look at this, we have two events that we're interested in. One event is that the sum of the two die is going to be an 8, right? And that means this right here, this diagonal line is right there. So how many total 8s do we have? 5 8s, right? Sorry, we have 5 of these out of a total of 36, right? Probability that the sum is 8 is equal to 5 out of 36, okay? 5 out of 36. Next, I need to figure out, well, what is the probability that one of the die is a 5, right? We had they add up to 8 or one of the die is a 5. Well, for this particular 6, one of the die is a 5, namely the green one is, right? For this 7, one of the die is a 5, namely again a 5 green. And so it looks like I would actually need to take a look at this entire row right here. Do you see this? The entire row. That is if the green one ends up 5. Those are the possibilities. And maybe let's make that a slightly different color. Maybe green. There we go. So how many are there? 1, 2, 3, 4, 5, 6. 6 possibilities, right? And then over here I could have actually a red 5. Here we go. And that gives me 6 possibilities as well. Right, so one or the other is 5. I can probably erase these here, and so write down probability that one of them is 5. That would give me 6 of these, right? And then 6 of these, 12. So 12 out of 36. And now the question, the last question that we have to answer is, are there any overlapping? Because we don't want to double count, right? Are there any overlapping? And there are several that are overlapping. Here are those that are overlapping. This 10 is overlapping. So that 10 was counted twice, right? This 8 was counted twice. And this 8 was counted twice. So we have 3 things that were counted twice, and so I have to subtract out one copy of the intersection if I'm going to say, find the probability that the sum is 8 or one of the outcomes is a 5. And that's what we have in the slide here. We have 5 36 plus 12 36, 5 36 plus 12 36 minus the 3 36 that were in the intersection. There's a 10 was counted twice, and there are 2 8s that were counted twice as well. And so we get 1436, which is the same thing as 7 8s, or about 39% chance of getting A or B to happen. Either they add up to 8 or one of them is a 5. I hope that in-depth look at this exercise helped you understand why we have, again, subtract the intersection. Okay, there's a rule for complementary events because if you think about it, the A and its complement actually equal the entire space, then the probability of getting A or its complement is going to be equal to 1. Note that probability of A union B, because they're mutually exclusive, there's no overlapping between A and not A. We have probability of A plus probability of A complement minus their intersection. This intersection is 0. There is no intersection between an event and its complement or a set and its complement. Then we have probability of A plus probability of A complement is equal to 1. So we can rearrange this formula right here to say probability of A is equal to 1 minus probability of its complement, and probability of A complement is equal to 1 minus probability of A. Okay? So keep that in mind for complementary events. Here's another example of probability. You have an urn with 2 green marbles, 3 red marbles, and 4 white marbles. Let A equal choosing a red marble, and B choose a white marble, both with replacement. That's actually very important, and it's key, because when you're replacing, you're not changing the total number of marbles. And then there's these 3 questions. What is the probability of choosing a red marble? Well, how many total marbles do we have? We have 2 plus 3 plus 4. We have a total of 9 marbles, right? And how many of them are red? 3 of them are red, so 3 out of 9. Number 2, I guess 3/9. What is the probability of choosing a white marble? There's 4 out of 9 that are white. That's the probability. And then what is the probability of choosing a red or white marble? Well, a red or white marble would just be the addition of 3/9 plus 4/9, which is equal to 7/9. Let's think about why these 2 events are mutually exclusive. Well, if we have these, think about this, if we have these green, red, and white marbles, what does it mean that I would have a green and white marble, right? Or a green and red marble? That means that same one marble has both colors on it, red and green, or red and white, or green and white. And there is no such marbles in the urn. There is only green marbles, and there are red marbles, and there are 4 white marbles, right? So there are no red and white marbles, or green and red marbles. That's why these 2 are mutually exclusive. And therefore, I just needed to add the 2 probabilities. That's as simple as that. So here's that card again. I'm going to actually break apart this video, but we're going to do some more exercises with probability and the addition rule in the next video, and some of them are going to be with cards.